morning, math humans. We are going to do 5.2 today. We're going to be integrating trig functions with the natural log function. Our objectives are that we're going to look at more integration techniques, and then we are going to integrate some trig functions and the natural log function. So I've pre-written out all of the formulas for you. So if you want to take a moment and pause and write all these down, this one technically is not a formula, but I wrote it so that we will remember to talk about U substitution. All right, let's jump in with our first example. So for example number 1, we're going to have the integral of x squared plus x plus 1 over x squared plus 1. So this one is a little bit of a unique situation. The degree is the same, top and bottom. So I'm going to start by doing long division. So I'm going to divide x squared plus 1 into x squared plus x plus 1. X squared divided by x squared is 1. And I get x squared plus 1. Change the signs. And I bring down and I get x. Okay. So then I can rewrite the integral to be 1 plus x over x squared plus 1. Remember that we always want to make sure everything inside the integral is in parentheses. This is easy. So technically I could split this up into two integrals, 1 dx, and then the integral of x over x squared plus 1 dx. This one's super simple. This one is just easy U substitution. So if I let u equal x squared plus 1, my du is 2x dx, so I need to introduce a 2. And I'll get to that in a sec. So the integral of 1 is going to be x, and I'm going to go ahead and put my plus d right there. On this one, I need a 2 on the inside, so I introduce a half on the outside, so this is going to be 1 over u du. And so when I integrate this, I'll put it down there, this is x plus c plus 1/2 natural log absolute value of u. I already put a plus c. Remember that there's only one constant of integration, so I don't need to have multiples. So this is going to be x plus 1/2 natural log absolute value, x squared plus 1, and then there's my plus c. And I would say that this is the integral of f of x dx. So that wasn't so horrible. Okay, second example, example number 2, says solve the differential equation All right, and we're going to be given dy over dx is equal to 1 over x natural log x. So remember, if I'm solving a differential equation, I need to separate my variables. And remember, when you take your AP exam, that just showing that you have separated the variables often earns you a point on an FRQ. So I'm going to do dy is equal to 1 over x natural log x dx. I'm going to integrate both sides. So I'm going to get y is equal to the integral of 1 over x natural log x dx. I'm going to do u substitution again, so I'm going to let u equal the natural log of x. My du is 1 over x dx. I have everything I need, so y is going to equal the integral of 1 over u du, which is just the natural log absolute value of u plus c. And so I'm going to say y equals, and I'm going to substitute my u back in, the absolute value of 1 over x. My bad, faulty substitution. I was going to say something doesn't look right, and I need to move it up so you can actually see it. We're just not batting 1,000 this morning. There we go. And then now I add my plus c, so I guess I could write this more politely. Natural log, absolute value, natural log, and then plus c. All right, so we have a couple more examples, kind of a short video today. That's kind of nice. So the third example says evaluate and of course we're going to put by hand because we can, and we're going to have the integral from 0 to pi over 4, and I'm going to have 1 plus tangent squared x dx. So if you'll remember from pre-calc, 1 plus tangent squared x is secant squared x, and the square root of secant squared x is just secant x. So this becomes the integral from 0 to pi over 4 of the secant of x dx, which is a lot simpler than the way that the problem actually started. Alrighty, so then I have a rule for the integral of secant of x, so this is going to be the natural log, absolute value, secant of x plus the tangent of x, and then we're going to evaluate it from 0 and pi over 4. So this is the natural log secant of pi over 4 plus the tangent of pi over 4 minus the natural log secant of 0 plus the tangent of 0. Okay? So if we do all this math, the secant of pi over 4 is going to be the natural log, it's radical 2, and then the tangent of pi over 4 is 1, minus the natural log, the secant of 0 is 1 plus 0. Okay? So then this piece is the natural log of 1. The natural log of 1 is 0. So then my solution is going to be the natural log of 1 plus radical 2. And that would be my integral of f of x dx evaluated from 0 and pi over 4. So yay, Trig. All right, we have one more example. So example number 4 says find the average value f of x is equal to the tangent of x on the interval from 0 to pi over 4. Okay. Well, remember that your average value is going to equal 1 over b minus a integral a to b f of x dx. So this is going to be 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 tangent of x dx. Okay? If I clean up my math just a little bit, this is 4 over pi, integral from 0 to pi over 4, tangent of x dx, because I just managed that fraction out front. And then when I integrate tangent, I'm going to get, here's 4 over pi times a negative natural log absolute value, cosine of x, and then I'm going to evaluate from 0 to pi over 4. And then if I do this math, if I substitute everything in by hand, or I can use my grapher, then I'm going to get a 0.441. Remembering that when you evaluate an integral, a definite integral, it's always the top index minus the bottom index. Okay, that's it for today. Nice short video. I will see you soon.